The global balance of power has shifted. Mastery over artificial intelligence has become the primary metric for 21st century geopolitics. Sustaining AI primacy requires dominance across four distinct battlegrounds: data, computing power, talent, and institutional implementation. Computing power is the immediate physical bottleneck. Access to advanced photolithography machines, required to etch microchips onto silicon wafers, serves as a massive geopolitical lever. Because the semiconductor supply chain is hyper-concentrated, the sterile, highly specialized cleanroom facilities that house these fabrication lines dictate who can physically run advanced models. Technology is equally bound by human capital. Dominating the field requires an open, global funnel capable of cultivating and retaining the world's top machine learning researchers. Hardware and talent stall without institutional implementation. Military and government organizations often struggle to deploy agile software within rigid procurement frameworks built for industrial-era hardware. This creates a cultural chasm. On the battlefield, algorithmic command systems operate at machine speeds, where human reaction time becomes a severe operational liability. Among these four battlegrounds, data presents the most continuous and volatile risk. While computing power is a bottleneck of physical scarcity, data is a bottleneck of friction. Like raw gold in the earth, it has zero utility until it is refined and integrated. Authoritarian models manage this friction through centralized surveillance, treating all domestic information as a unified, state-accessible lake for machine learning optimization. Open societies operate within fragmented ecosystems defined by corporate silos, localized architectures, and strict privacy regulations. For emerging markets, the challenge is to secure high-quality, verified data pipelines without replicating centralized surveillance or succumbing to fragmented silos. Achieving digital sovereignty requires a shift from passive collection to active refinement, designing a system that processes raw information into a verified, sovereign asset. We call this architecture the Crucible. The Crucible functions as a three-tiered system designed to guarantee structural data integrity from the moment of origin. It begins at Layer 1, the edge. In this model, we process information directly at its source to maximize systemic agility. Traditional models often suffer from latency by sending raw, unrefined data back to centralized cloud servers for secondary processing. By embedding low-latency devices at the point of origin, a factory can monitor and optimize manufacturing yields in real time. This applies equally to sustainable development, such as monitoring treatment lines in bamboo production. Localized decision-making enables these systems to react instantly to environmental or operational shifts before the data ever leaves the site. When these devices utilize standardized communication protocols, diverse physical industries begin to speak a universal, interoperable digital language. However, data collected at the edge is only useful if the storage pipeline remains tamper-proof as it moves between different industries. Relational databases are structurally insufficient for this task, as they lack the immutable audit trails required for trustless, cross-industry pipelines. This deficiency exposes the system to data poisoning, where adversaries intentionally taint public datasets to compromise the downstream AI models that rely on them. If the foundational training data is corrupted, the entire system inherits those systemic vulnerabilities. Layer 2 acts as the refinement stage of the Crucible, using Web3 frameworks and cryptographic provenance to verify every input. This layer functions like a digital forge, guaranteeing an immutable history of the data's journey and burning away any unverified or corrupted information. This allows for the authentication of physical creative assets, as seen in the Ex Nihilo Waste-to-Art project. It also provides the audit-ready metrics required for institutional capital allocation based on cultural ESG benchmarks. Cryptographic provenance transforms data from a high-stakes liability into a verified sovereign asset. The final stage of the architecture addresses the operational friction of managing cross-border compliance and user access. Attempting to retrofit modern data protection laws into older, mature systems is often an exercise in administrative failure. Layer 3 utilizes compliance by design to bake these regulations directly into the system's access layer. Coding data protection laws into the software ensures that real-time permissions are dictated by the system itself, rather than by manual oversight. This is supported by a zero-trust architecture. In a zero-trust framework, no user or system is blindly trusted, regardless of their location inside the network. Making access a structural defense completes the Crucible, allowing data to move securely across sovereign borders. Deploying this architecture in high-stakes environments highlights the difficulty of moving from raw potential to execution. The agile framework of the Crucible must often compete with the established culture of national defense procurement. This is the innovator's dilemma, the clash between the fast-failing commercial tech sector and the zero-fail mandate of government bureaucracy. Without verifiable data integrity, these legacy institutions cannot absorb the cutting-edge frameworks required to maintain a technological moat. Rigorous auditing at the input level provides the only viable bridge, satisfying institutional risk aversion without sacrificing software speed. By framing strict compliance as an unmovable regulatory baseline, organizations can maintain productive partnerships between tech innovators and bureaucratic regulators. This alignment allows agile AI software to function safely within industrial-era institutional structures. For emerging economies across Africa, the immediate opportunity lies in the digital market's inherent dynamism. These regions possess the talent and market scale to position themselves as leaders in the global digital economy. While hardware fabrication and talent retention remain significant hurdles, the structure and verification of data are battlegrounds where sovereignty can be designed from day one. By building data integrity into the stack through edge computing and cryptographic proofs, nations can secure their information assets against external manipulation. Digital sovereignty is not a passive outcome of technological adoption. It is a result of intentionally designing the systems that refine our most valuable resource.